Hello everyone, I'm Vivek from K4 Metrics and we support SmartUQ in India. In the previous video, we saw how we can take the data from CAE solver if it is not integrated with SmartUQ. In this video, I'll be showing you how we can take the data to SmartUQ, how we can create the surrogate model, how to check its accuracy and how to improve it. With this, let me just shift to this Excel sheet which shows the input parameters, that is the sliced one parameters. And this is the Y matrix, that is the output parameters which I got from ACU2. In the previous video, I explained what these columns depict. So the first column is the slice number. The second is the DOA number. The third is the iteration number, that is the iteration at which the solution got converged. The next three columns are just the input parameters, that is free stream pressure, angle of attack and mark. The last two columns are coefficient of lift and coefficient of drag. So these two are the output parameters. So I'll just save this. You can, if your solver doesn't write the column names, you can either do it from the Excel or a text editor, or you can add the names of the columns from SmartUQ as well. So with this, let me just go back to SmartUQ, and here I load the slice X and Y matrix for slice 1. So these are the input parameters and these are the output parameters. So if I expand this, you can see that I can change the name here. So now that I have the input and output parameter with me, so I'll go ahead and create the surrogate model. So I'll go to the emulate option, and you can see that SmartUQ offers you various kinds of emulators, and for this example we'll be taking up continuous response emulator. So I'll select X matrix for input and Y matrix for output. I'll go to pick from list and I'll only select the input parameters because I do not require this slice number, and here I'll only choose the coefficient of drag and lift. So keeping everything else default, I'll just click on submit and this will give me the emulator. So if I click on emulator, the first thing I'll be seeing is the CV plot. So this is nothing but cross validation plot. So cross validation is a common method in statistics which is used to determine the accuracy of a trained model. So this is created based on the leave one out prediction. So how this works is, so it will take the complete input parameters, and in the output matrix, it will leave the first simulation output. It will take from 2 to 15, and using these data, it will predict the simulation output for the first simulation, and it will compare it with the actual output. And then it will add the first point here. Similarly, it will take the complete simulation inputs and it will leave the second simulation output. It will take simulation 1 and simulation 3 to 15. Using this, it will predict the output for the simulation number 2, and then it will compare it with the actual output and it will add the second point. This process is repeated until it reaches the bottom of your matrix. And the main thing that we have to look out here is the standardized CV error. So the recommended value for standardized CV error by SmartUQ is to have this less than or equal to 0.05. This will give you the information on how accurate your emulator is. So now you can see that for CD it is 0.2 and for CL it is 0.5. So clearly my emulator is not accurate and I have to add more data points to make it accurate. As I've shown in the previous videos, I had taken multiple slices so that I do not end up with repetitions in the input parameters. So that is one way of doing it. In case if you have just created a normal DOE in SmartUQ, the way to add more points is the design augmentation. So if I go to DOE, you have the design augmentation where you can select the DOE you would have created and you can add move points to the existing DOE and then take that to the simulation software. So there is a link from SmartUQ website which explains the DOE adaptation and augmentation. So I will leave the link in the description. So in order to improve this, now what I'll do is I will load the details from slice 2. I'll click on open, and what I'll do is I'll go back to slice 1 and I will click on add. Keeping the row orientation, I will select the X matrix of slice 2 and I will click on submit. So now I will get an X matrix which has 30 simulation inputs. So let me just rename this slice 1 and 2 matrix. And similarly, I'll go to Y matrix, I'll click on add, row orientation and slice to Y matrix. Click on submit. This will give me 30 rows and 8 columns. So I'll just rename this one as well. So now I have new X and Y matrix which I'll be using. I'll go back to emulator, continuous response emulator. For input, I'll select the 30 into 4 and output will be 30 into 8. So I'll just filter out the values that I require, and with that I will go ahead and create the second emulator. So if I go to the emulator, as you can see now, the standardized CV error has come down comparatively from the first simulator. So for CD, you can say it is 0.05 now, and for CL it is 0.2. So there has been clearly improvement in the error rate. And in order to improve this further, I just need to add more number of data points. So let me just shift back to my presentation. So here what I have done is, uh, so first I did this slice 1 and slice 1 and 2, which I showed right now. So I continued the process and I kept on adding more slice details and I created emulator for each of them. So as you can see from the chart, at the initial rate, there were a lot of fluctuations, and by the time I reached slice 17 and 18, the standardized CV error started becoming more and more constant, and this gave me the indication that it is getting converged. So I stopped at slice 21. So now I know that my emulator is accurate enough for my further studies. So this will be the end of the third video, and in part 4 I'll be showing this emulator and I'll show you how we can use it to perform these 4 studies. So if you have any questions on what I have shown in this video, you can drop a comment down or you can email us at support@keyformetrics.com.